In order to understand how dynamic programming works, we need to understand what caching means. Caching is a way to store values so you can use them later on. Ideally, you can think of caching as a backpack that you take to school. Instead of going all the way home when you need something like a pencil, you have a small box on your back that holds items that you need, so that when you go to school, you can just reuse them fast over and over. Now, that's a bit of a silly example. Caching is just a way for us to speed up programs and hold some piece of data in an easily accessible box. And memoization is a specific form of caching that we're going to be talking about because we use it a lot in dynamic programming. But instead of just talking about it, let's actually demonstrate it in code. The way we can cache things, well, let's imagine we have a function that says we want to add to 80. And this function takes a number, and all it does is return the value of n, that is the parameter we give it, and adds 80 to it. So that when we run the function add to 80, and let's say we put in 5, we get 85. Nice and simple, right? But if I run this function again, I'll have to go through this step again and add 80 to that answer. And if I do this again, do the same thing. I've ran the calculation 3 times. But what if this operation took a really, really long time? What if I had a console log here and we can imagine that this operation takes multiple seconds? It takes a long time. Every time we run this function, we'll have to run long time 3 times and go through the step one by one, even though we've done the exact same calculation 3 times. Is there a way that we can optimize this? And this is where we can use caching and memoization. Let's improve the above function by doing something different. I'm going to create a new object called cache that's going to hold an empty object. We're also going to have a function that is now going to be called memoized, not memorized, memoized, add to 80. That takes a number. And inside here, we're going to do something a little bit different than the above. We're still going to add to 80, but we're going to do it in a special way. I'm going to say that if n is in cache, and this is a way to check if a property exists in an object in JavaScript. So it's similar to me doing cache.n to check for the property. This one just reads better, so I'm going to keep it like that. So if n exists in cache, so if we've cached it before, then simply return the cache.n or cache n. So return the cached value. But obviously it's empty the first time around, so this is not going to work. If there's nothing in the cache, which is the case the first time around, well, we have an else statement. And in here, we're going to have our cache n, which doesn't exist yet, and assign it n plus 80. So that after this, if we do something like memoized add to 85, it's going to say 5 plus 80. So in here, we're going to cache the property 5 to have a value of 85, which is what we're doing here. So that the next time around, we're doing something like this. We go through the if statement, find the fact that we've already calculated 5, and just do simple property access, which, as we know, is all of one time, is super fast with a hash table like this. Let's complete this example to show you how it works. I'm just simply going to return cache n, since we just filled it up here. And let's just have a console log here that does long time to see that we're doing the calculation that takes a long time. The first time I run this function, I get 85, and oops, I have the cache pre-filled, so it didn't calculate the long time. Let's try that again. Click run, long time. The first pass through, it went through here and did this calculation that hypothetically is going to take a really long time. Again, we're using a nice, easy example here, but you can imagine this being a calculation that takes a long time, many seconds. What if we do this again? We can console.log here to make sure that we capture these values. And we'll label them 1 and 2, just so we can distinguish them. So the first call and the second call. If I hit run, look at that. First time around, we call long time and we calculate to 85. But the second time around, because this value was in the cache, we didn't have to do this long calculation and we just returned it immediately. So what is memoization exactly? Well, memoization is a specific form of caching that involves caching the return value of a function, that is, the return value of this function, based on its parameters. And if the parameter of this function doesn't change, like it is here, then it's memoized. That is, it uses the cache because it's calculated the same thing before with the same parameter, and it will return a cached version of the function. It's memoized. If the parameter changes, well, it's a different parameter that it's never seen before, so it's going to calculate both times different things. And I just noticed here that this shouldn't be 5, it should be n over here, so it's dynamic. There you go, that's better. So remember this, memoization is simply a way to remember a solution to a solved problem. So you don't have to calculate it again.